Welcome back to our setup tutorial. In this video we will install the SOGNO Service PyMFM on our freshly installed K3s cluster using pure Kubernetes resources. As always, the reminder that this is part of a series, so if you are not aware of the previous videos, you might want to look at those first. There is also an even more elegant way to install the service using Helm, which I will show you in the next video. Only one installation is needed, of course. Using pure Kubernetes resources is a little bit more involved, but also teaches us a little bit more about Kubernetes. Please note that SOGNO is constantly in development, so details might have changed, but hopefully this tutorial will still make the steps clear enough to install the service. Okay, without further ado, let's install PyMFM. The first thing that we should do to keep our cluster tidy is to create a new namespace to work in. For this, we just run kubectl, create namespace, and then the name of our namespace. I will call mine SOGNO PyMFM. It doesn't really matter what you call it, but of course you should be able to tell what it is in a month or so. And our namespace was created. Let's see if we can see it. Get namespace. And we see all the namespaces that exist on our cluster. And there is our newly created one. If anything went wrong or you decided on a different name for the namespace, you can always run kubectl delete namespace and then the name of the namespace. I will not do this because I'm fine with the name. Now we will do an optional step, which is setting the namespace as default. For this we need root access, and we are running sudo kubectl config and then set context. We are in the current context, or we want to change the current context. And we want to set the default namespace to the namespace we just created. This is very convenient and saves us a lot of typing, but it can also be a little bit messy, since this is a permanent change to the config, and if we come back in a month or so, we might have forgotten that we changed the default namespace and will install components to the wrong namespace. If you prefer to not set the default namespace to the one we are working in currently, you can always add a flag n for namespace and then the namespace to all the kubectl and helm commands. This is too much typing for me, so I will just set the default namespace. The next thing that we need to do is that we have to generate two secrets, one for the database that we are running and one for the access to the API. This step is always a little bit different for each SOGNO service, since the required authentication is also a little bit different every time, but in general this is a necessary step. For each service there is an explanation on what is exactly needed for the installation beforehand. For obvious reasons, we cannot provide any credentials to you as you are running your own version of the service. So let's create a password and username secret. For this we run kubectl create secret. We want a generic secret. I will call the one for the API PyMFM API out. You can call it whatever you want. Same thing applies as before. It should be obvious what the secret is for. And then we created from literal. That is the first key, and the first key we need is a username. Capitalization is important here. And I will call the username admin, and again from literal the second key, which is called password. And I will also name this admin. As I said, this is surely not secure, but enough for testing purposes. I was missing a second dash here, and now the secret is created. We do the same thing for a Redis secret. I will just use the same username and password, but of course you can use whatever you like. I highly advise not to use any secrets you currently have in production anywhere else, as we will not set up encryption, and anything going through HTTP pure requests might be readable to someone outside. Now our secrets are set up, and we can check whether we can see them by running kubectl get secret. You might see a pattern here. In case you ever forget the contents of your secret, you can access them if you have access to the namespace they are in by running kubectl get secret PyMFM API out. So this should be a slash. So the name of the secret, and then -o JSON path equals, and then in strings dot data. So the data that is contained in the secret, and we want the password key from this secret. This will be in base 64, so we still have to decode it by running base 64 and the -d flag for decoding. And we see here it's a little bit wonky, but we see there it's our password again. Okay, all the other resources that we need to install are available on our example deployments GitHub page, which can be seen here. And under PyMFM, we see all the deployments that we need. I also downloaded them so I can show them to you more easily, but you can install them directly using their links. For example, the stateful set. If you click on raw, you can use this link directly for installing. I will show you in a second. Okay, let's change into our PyMFM folder where I downloaded all the resources that we need. I also have an explorer here on the side, so we can open them directly. The first thing we will install is a stateful set. A stateful set is very similar to deployment. We talked about it, just as the name says, adds statefulness, so it is the correct type for databases and the like, if you are running them in Kubernetes at all. Otherwise, it looks very similar. What we are using here is an image from Bitnami, and they provide an image for Redis. Redis is a key value storage that is a pretty light database and pretty easy to handle, and is all we need for our result storage. The maybe most interesting part of this file is the part where we give access to our password that we just created, which is down here under the env tab. Here we can see things that are provided as environment variables, and we are providing an environment variable called Redis password. This we should not change as it depends on the image itself and is set. But here we say where the password is coming from. We are using the password key from the secret PyMFM Redis auth. The secret has to be in the same namespace, and of course, if you change the name, you need to change the name of the secret here as well. Okay, since I didn't change anything, I can apply it straight up. To do this, I just have to run kubectl apply, then -f, because I'm applying from a file or from a source, and I will apply the stateful set Redis YAML. Okay, done already. Let's see. Okay, there it is. Here's the stateful set, and here's the pod it created. It is still in creation process. Let's see if it's already done. It will take a couple of seconds to start up. That is pretty common for databases. And there it is running. Okay, the next step is to provide access to this database by applying the service resource. The service resource is also just the same available on our GitHub, and the only thing that we should note is that our selector here is run PyMFM Redis, which is exactly the label that we added to the pod in our stateful set. Also note that we chose cluster IP as a type, as we don't want to give direct access to our database from the outside. Okay, this time I will show you how to install from GitHub directly. This is not very difficult. We just navigate to our example deployments page, look for the correct file, which is the service Redis, use the raw link, and then we can use it just as we did before with the file path and the link, and the service was created. There it is. Okay, now we do the same with the deployment of our API, which is under the deployment API YAML file. Here, if you change the names of the secrets, we have under env again 3 different keys that we provide to the container: a username and a password for the API. And of course, the API itself has to talk to the database, so it also needs the password for the database. Additionally, this doesn't need to be changed, but we have already seen that we can talk to this service by just using its name, and this is exactly what we are doing here. So if this database was running outside, we could put some URL here, and it would work just the same if the database is available under there. But of course, this is not the case here, so we will leave it as is. Okay, let's see again if it started up. Again, container takes a little bit to create. Maybe I can tell you something about this appendix here. This is just random gibberish to make sure that the names of the pods never collide. While for the stateful set, they will count up because there is a specific order to the pods, how they are created. Okay, and there it is running. Okay, the next thing we are installing is a service to reach the API. Again, our selector matches exactly the labels of the pods that are created by the deployment of the API. This time, however, we've chosen the type node port for the service, so we can access the service directly by using either the URL or the IP address of the host machine. Or if you're running on a bigger cluster, any of the host machines. So again, let's apply it. Okay, let's see. This time we will only look at the service. These are always really quick to create. The pods that are shown here are on the left, the internal port, where other services or other pods can communicate with this service. The latter one is the port for outside. As I already said, the port range is basically random in the range from 30,000 to 40,000. Okay, let's see if we can access our service here. And this is of course my IP address and not yours, and it's also not available from outside, but here we have it. There's our service running. This is the Swagger UI we have already seen, and well, I can show you everything is running how it should. Well, of course we should test this. First, we see if there's any jobs already there. This is very nice. It already asks me for my credentials, which I will add. And then it will tell me that there's no jobs currently running or any results available. So what we can do is run an example job. We use the post method for this. We can use this nice interface directly, which will give you a non-working example here, but just for structure. But if we post our example from before here, we can run execute and see this is the command. If we would run it in curl, it's pretty long because we have to put in the whole time series that we predicted, but the response gives us the ID that we needed to accept the result. And let's minimize this again. We can see if we run the normal get endpoint again, there is the one ID that we just generated. Next, we will see for the result. The optimization is usually quite quick, but let's see. We execute this and get a response here, where again we are reminded of our original input, and then further down, a lot further down, still input. Yeah, we can see this. There's a status success. The details say optimal, so an optimal solution was found when the job was created, and then the result, again the ID, just to identify the result with everything else, and the schedule for our 2 batteries. Okay, great. This worked, everything seems fine, so we don't need this test job anymore, so let's delete it. We just enter the ID here and run this endpoint. It will respond with what the object is that we just deleted, just to remind us. But if we run the normal get endpoint that lists all available jobs, again, we see there's no jobs available anymore since we deleted them. Great. Now we have some insight in how to deploy a SOGNO service on Kubernetes. I hope you understand the basic concept of Kubernetes a little bit better now. Still, if you think this was a bit tedious, I completely agree. That's why I will show you a different method to install all resources other than the secrets at once in the next video. For this, we will use Helm. Okay, see you there. Bye.